Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to find the cube roots of a complex number. I say the cube roots because a complex number has 3 cube roots. I could also write this as 18 plus 26i to the power 1/3, but it wouldn't look as good. Anyways, let's go ahead and dive into it. By the way, in the meantime, I'm working on the cube root of a complex number, a formula that we could use in general. I made a lot of progress. Hopefully, I'll share with you pretty soon. Anyway, so let's get started. We have the cube root of 18 plus 26i. We don't know what it is, and that's a complex number. At least we know that, right? Well, there are 3 of them, but let's just set this equal to a plus bi. I'm also going to show you some results from WolframAlpha, which I think is pretty interesting. But I think my solution is better. Anyways, no worries. So if you go ahead and cube both sides here, so this is what I should be doing next. And switch sides. So this is what I'm getting. I get a cubed minus 3ab squared plus 3a squared b minus b cubed. That will be my imaginary part, right? And then this should equal 18 plus 26i, okay? Now, from here, I get a system of equations because this is supposed to equal 18 and this is supposed to equal 26. Awesome. This gives us a system, but not just an ordinary system. It gives us a homogeneous system, which is really, really cool because if it wasn't homogeneous, you would be in big trouble. So since this is homogeneous, just like differential equations and any other type of equation, we can solve it by changing the variable, right? Okay, cool. Now, how do we change the variable? I'm going to call this b equals at, the BAT formula. Okay, great. It's not a formula. It's just substitution. If you replace b with at, you get the following. You get a cubed minus 3a cubed t squared equals 18. By the way, I'm trying to keep a long story short here. And from the second equation, you get 3a cubed t minus a cubed t cubed after doing all those simplifications equals 26. Now here's what we're going to do. This is going to be real cool. We're going to divide these equations. By why? Because the reason why we did this substitution, obviously there's a good reason behind it, is that a cubed can be cancelled and we're going to end up with a single variable. Isn't that cool? That's what homogeneous means basically. Now we're going to be getting a cubed on the outside, 1 minus 3t squared. That'll be divided by a cubed times 3t minus t cubed, and that'll be 18 over 26, which I can write as 9 over 13. A cubed cancels out. If you do the cross multiplication and put it all together, again, I did it for you, you're going to get a nice cubic equation. Trust me, it's not going to be that nice, but anyways, I'll still show you what it is. It's basically going to look like this: 9t cubed minus 39t squared minus 27t plus 13, not minus, equals 0. And this equation, guess what? Is factorable. If you try the rational root theorem, which is going to be super painful, you're going to find the solution. And I'll show you a kind of like an easier way to get there. But before I do that, let me go ahead and show you, or just give you, the factors of this cubic equation, okay? So here's how we can factor. And how did I find it? You can just plug it into WolframAlpha. It's going to give you the solutions, right? So these are the factors, and which means that if you set this equal to 0, you're going to get the solutions. But let's do something smarter, something more algebraic. Multiply this equation by 3, and the reason for that is I want to get a perfect cube in front of t cubed. 3 times 19, 3 times 39 is 117, I think, right? And that's divisible by 9, it should be. 81t, everything should be divisible by 9, almost. As much as possible. So this can be written as 3t cubed. You get the idea? So now what I can do is I can basically write this as a polynomial in 3t, which is nice because then I'll change variables. Basically, you could also do that a little differently, but in this case, I can go ahead and replace 3t with something. How about k? That gives me k cubed minus 13k squared minus 27k plus 39 equals 0. And guess what? If you check the coefficients, 1 minus 13 minus 27 is negative 39, plus 39 is 0. Yay! K equals 1 is a solution. You should always check that first, right? Because k equals 1, k is equal to 3t, and that's equal to 1. This means t is equal to 1/3, which is also verified by this factor, right? 3t minus 1 equals 0 means t equals 1/3. Great. So what does that mean? b equals at, and t is equal to 1/3, so that just means b is equal to a divided by 3, or better yet, a equals 3b. 2b, I missed it, but you get the idea. So let's go ahead and plug it in. My first equation was this. Now replace a with 3b, you're going to get 27b cubed minus 9b cubed equals 18, which is very convenient, right? 18b cubed equals 18. How nice. From here we get b cubed equals 1 and b equals 1. But a is 3 times that, so a is going to be 3 from here. Which means, and this is significant, but this is not the funnest part. The fun part is coming up. The cube root of 18 plus 26, I remember we assumed that it was a plus bi, and now it's 3 plus I. If you don't believe that, go ahead and cube 3 plus I, and you should be getting 18 plus 26i. Very easy to check, right? You can do that. Okay, now, this is not the fun part, because remember I told you a complex number has 3 cube roots, and this is just one of them. And if we leave the video at this point, it's not going to be fair, right? We have to find all the cube roots, right? So how do we find them? Well, I kind of checked with WolframAlpha, and as for WolframAlpha, first of all, I asked for the cube root of this number, and it gave me this one. And like, there's only one. Of course, WolframAlpha always gives you the principal cube root, which I believe is this one. But then I kind of used a different prompt, and I got these, right? Of course, if you ask the question differently, it's AI, right? And it gave me this answer, but I don't like it because you know what? This is numerical and it's just approximate values. And tan inverse, come on. Are you talking about arctangent of something? This is not good WolframAlpha. I'm pretty sure you could do better than this. But anyways, that's too numerical. Let's go ahead and do it in a more algebraic way. I'll show you how it's not too hard at all. Now, we found that the cube root of 18 plus 26i is 3 plus I, right? Great. In other words, we know that 18 plus 26i is 3 plus I to the third power, correct? Yes. I know I keep writing the same thing, but it has a meaning. Look at that. So pay attention. Now, I'm going to go ahead and multiply the cube of this number by 1. But then I'm going to complexify the 1. And how do you complexify 1? You can write it as e to the power 2 pi ni. N is an integer. I'm not writing it, but I said it, right? So now, look at this. This is the cube of a number. If you go ahead and cube root both sides, like here and here, you're going to get this, multiply by the cube root of this, which is e to the power 2 pi ni divided by 3. Very easy. In exponential form, you just divide the exponent by 3. Awesome. Now, n equals 0, obviously, is going to give us 3 plus I. We already know that, right? Come on. But n equals 1 is going to give us something different. 3 plus I multiplied by e to the power 2 pi I over 3, which can be written as 3 plus I times cosine 2 pi over 3 plus I times sine 2 pi over 3, which is negative 1/2 plus root 3 over 2i, the second quadrant, right? And if you simplify this, you're going to get something like this. Negative 3 minus root 3 divided by 2 plus 3 root 3 minus 1 divided by 2 multiplied by I. This is what WolframAlpha does not produce, and I'm kind of disappointed, okay? Anyways, humans are better than AI still. And if n is equal to 2, so far, right? The next value is going to be e to the power 4 pi I over 3, and I'll show you a graph which kind of explains this visually. And of course, you're going to multiply by the 240 degrees, the trigonometric values. That's going to be in the third quadrant. Everything is negative. And now you're going to get from here negative 3 plus root 3 over 2, and then plus negative 1 minus 3 root 3 over 2i. That's just going to be the other cube root. So here we go. I gave you all the numerical values, but I have more to show you, so hang in there. First of all, this is the result I already shared with you. This is the WolframAlpha with the arctangent. So ugly, right? And these are the roots. Now, let me tell you something. If I take one of these roots and cube it, ta-da, I get 18 plus 26i. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.